Welcome to Not.IE, exploring the new possibilities in web development now that Internet Explorer is retired and I don't have to support it anymore. The topic is reactivity, or the closest thing we have to it in native ES6 components. The practice I'm showing today are used in real-world web apps deployed to production sites. No third-party JavaScript libraries used, no React, Vue, Lit, Angular, any of those. Nothing wrong with them. Just not being used, and there's business reasons for that. So this video, I'm going to break it down into two types of reactivity: traditional and building components that can react to each other and can react to changes. And that's the more interesting topic of this video, but I felt I needed to first break down traditional reactivity before we dive into the second piece. First, traditional reactivity. If you are a React, Vue, Lit, Angular developer, you get reactivity for free. Change your data and it automatically updates on the DOM. You get it for free or almost for free. Now, I'm going to assert you don't need as much reactivity as you think you do. In my experience, what I found in modern web apps is you really need a way to bind data to an HTML template. That's important. You need that. And I think that's the big value add that people are using a lot of these templates for right now, or a lot of these frameworks. And we have this capability available in native custom elements with template literals. You can see I kind of have two template literals here, and it's got some HTML, $, bracket. I don't want to turn this into a syntax video, but just know that you can do it. You see when I refresh the page, my data is John Doe. John Doe, I'm going to do Jane Doe. You can see as I'm deleting, the preview is updating. That's being reactive and binding. That's what we want. You can see no third-party libraries here. I'm just doing it all here with some template literals and a little bit of JavaScript. Vue, React, Angular, Lit, they all try to update the smallest piece of HTML on the DOM as possible in their reactivity engines. That's great. But I'll assert we don't need to be so surgical when building web components. What if we just rerun the whole template literal and overwrite the whole inner HTML in the component every time we need some data to change? I have found this strategy to be just as fast, if not faster. A lot less events are attached on there, and we get this on the cheap. Now, I don't want to go too deep into this because that's not really what I want to do a whole lot in this video, but you can see I have two template literals here, and the entirety of my code base is at first make an object. I put both templates on the page, and then I am watching this input, and every time the input changes, I'm extracting the data from the form and overriding this whole section of the DOM. It happens really fast. So that's your traditional type of binding or reactivity and templates working together, and I think I was able to do that pretty cheaply. Let's introduce our first example. We have a Hello World custom element. So we've got two buttons on the page, and a Hello World custom element. The buttons are just good old-fashioned buttons with events wired up. Show, hide, show, hide. And we're going to be expanding on this concept and eventually building up to something that I'd consider reactive or dynamic. All these are made-up functions. They're not part of the specification. And what I'm doing here, you can see we're painting H1 Hello World. It's in a function called template. I just made that up. I have that broke out because later we'll be calling template from a couple of places. Now, how it's wired up now is very imperative. Something has to select it, and something has to call show and hide. So we're going to work on improving that and changing this up a little bit through these examples. So here we're going to add the ability to say show from our code, not from the DOM, But if we say show, it's going to show. Now, how we're doing that is in our connected callback, we're just checking to see if it has an attribute called show and calling show. It's literally that simple. Now, quick refresher here, when you're building custom elements, you have about 4 functions on the API that you can use. You've got a constructor, you've got a connected callback, you have a disconnected callback, you have an attribute changed callback, and then an observed attributes function that helps support that. And I think there's like a moved one or something, but I never use that. So pretty simple, the API. And connected callback is called not when it's constructed, but when it's actually added to the DOM. That's an important thing to know. When the element actually gets ready to be presented on the page, connected callback is called. So now this is great. You know, we can come in here and in our code base we can do show. Didn't mean to do that. We can have it shown or not shown just by adding it there. But I really wouldn't call that reactive or dynamic yet, because that's in our source code. If I try to go do that in the DOM while it's running, nothing is going to happen. So, and the reason nothing is happening is because it's already attached to the DOM, and then the connected callback has already been run. It's already done. So what we're going to need to do next is let's try to add that functionality to make it so that we can actually make a change to our HTML in the DOM and have it be reactive on the and do some work. Now we're starting to get into what I'll call dynamic or reactive components. And you know, in JavaScript custom elements, the primary built-in way of doing things, you have 2 different ways of working with things. You either have events, you're creating events and dispatching events, listening to events, or you're using mutation observers. And mutation observers allow you to watch the DOM for changes. Now, custom elements has a built-in mutation observer that watches for attributes on itself. And there's 2 parts to it. One, you have to tell it the attribute names you want to watch, and then you have to implement this attribute changed callback function. And yes, you've got to get it right. If you misspell it, it's not going to work. And the signature is the name of the attribute. It'll pass in the old value of the attribute and the new value of the attribute. So in this case, we want our component to be reactive in the sense that if I go to my component and I add an attribute, now let's hide it here real quick. I want to add an attribute of show. Hey, it's shown. And I want to add an attribute for hide. Now you can see that I'm deleting those attributes right after they're being added, and I'll go into that here in a second. So this is the most complex example that I'm going to show with reactivity. And I want you to watch what happens when I type show. Notice how the class says fade in, it says shown, and this had a slow fade in. Here, I'll hide it again, and I'll just show it. See how it slowly fades in? And shown, the shown attribute does not get added to the component until after the animation is done. Now, I'm not saying this is a great example. I wouldn't do this I would not create a show and hide necessarily this way in a production app, but I'm trying to show the principle here and the mechanics of this concept. And the concept is here, I am separating out my commands and my state with the attributes. So I have an attribute that is a command to say show or hide. But the state that's being displayed for other components that might want to watch this is going to be separate. It's going to be different. And this example, I want to show you why I'm doing that and why that's kind of important. And because it's doing an animation, I think this is the easy way to do it. So I have a fade in and fade out, traditional stuff. I don't want to get into that. There's plenty of websites on all that. So my attribute change callback is the same as in the previous example, but what's changed here is my show and hide methods. When something calls show, if fade out happens to be there, I'm removing it. I'm adding fade in. Now, as a side note, I really wish I could use classlist.replace, but when you use replace on CSS selectors like this, they don't run, and it has to do with the index, or it's reported that it has to do with the index value being the same. So I don't use replace, I'm just removing the old one, adding it in. Then I'm adding an event listener here, and I'm waiting for the animation in, and this is traditional. You see this in all the JavaScript libraries and frameworks. They're waiting for that event, the animation to end to do something. I have a little test to make sure that I'm not picking up the hide, but I am removing the attribute of not shown and setting an attribute of shown. Now, in reality, you'd probably want to use hidden, or you could use some built-in native pieces, but I wanted to build this without side effects. So I'm just doing shown and not shown attributes. Let's go back here. Show, not shown after the animations finish. Now, this is not important for this component. This component doesn't care. It's just kind of broadcasting out of state. Now, this is just one way that you could do it. You could also do this with events. You could create an event here and dispatch that event. I'm not going to go into that here. There's plenty of tutorials about creating events and dispatching them, and then others listening to those events. And I think that's well enough known. But again, now in the next example I'm going to do, we're not going to make any changes to this class, but we're going to build a component that actually will watch this and react to those changes. Now we're getting into what I'll call reactivity in the sense of dynamic custom elements, in the sense that they're responding to changes either in the DOM or in other custom elements. Now, for this example, I've done some restructuring. I moved the hello world into another file just to get it out of the way, because that's not changing. That's not the interesting part. And I build this little lore ipsum component. See the template, just, enter HTML, just says some lore ipsum. So what happens is, after my hello world is shown on the page, it shows the lore ipsum. And it removes it after the lore ipsum, or after the hello world is hidden. Again, arbitrary example, doesn't matter. This is trying to get the mechanics of reactivity here. So this example, I am using a mutation observer to watch the hello world element, and when it says shown, lore ipsum will then show or be displayed, and when it's hidden or not shown, lore ipsum will clear itself out. So let's break down in the code here. So first I'm selecting my hello world, and then I'm calling this big long function name that I made, and I want to go break this down. I'm calling this element attribute changed callback because in custom elements, the attribute changed callback is part of the API. I wanted to simulate that same signature, but I wanted to make it so that I could pass in any element, because the attribute changed callback that's built into custom elements only cares about the custom element that you're working on. It doesn't care about anything else on the page, only the attributes on itself. It doesn't even care about child attributes, only its own attributes. So in this case, I'm selecting my hello world, and if hello world says shown, I want to paint lore ipsum, and if it's not shown, I want to paint lore ipsum, or I want to clear out the lore ipsum. So let's break down my element attribute changed function. I'm going to give it an element name and attribute callback. Now the big thing here is I'm just spinning up a new mutation observer, and I'm saying when the mutation observer is working, doing its thing, call this function. And we have a config here. You can see here that there's my element that I want to watch. In this case, it's hello world. But in my config, I'm telling it that I only care about attributes, and you might get a performance boost if you set this to false. I don't care about children elements or subtree or anything else. All I care about is attributes changed. So what does that mean? So every time an attribute changed, it's going to go through all the mutations that happen, because you got to remember this is real-time, mutations are coming in. So mutations are going to come in, and this line's probably redundant, but all I'm going to do is, you know, if it's not an attribute, just return, but I want to extract the name, the old value, and the new value out of the mutation that it's telling me about. And then I want to call the callback function that was passed into it. Pretty simple. Now, I have a couple of functions like this, some mutation observers, some that watch attributes, some that watch elements, some that wait for elements to get put on the DOM. I've got a little list of them, but they're pretty simple. You only have to build them once, and then you can reuse them all the time. And again, like I said, this follows the same signature as the built-in attribute change callback, which should make it easier to reason about. Hopefully I've provided enough information to help you build reactive components, whether they be reactive in the sense that the data is changing and you need to update the DOM, or that one component is watching another component via state changes. And I should bring up the point too that the reason why you might want to store state on an attribute, maybe the custom element that needs to react to that change isn't available on the DOM or isn't in play when an event is thrown. So if you go with events are kind of like they get fired and then they're done. And so that would be the use case where you would really need to probably have an attribute state on the attribute. Of course, a lot of these, like this show hide example, there's other ways of doing that. You could actually have not have a state at all, and the parent component could interrogate it to see if it's empty or whatever. The only downside of that would be if you change how you're doing show hide, all the other components may know a little bit too much about it. So being able to have an attribute that you can easily read for state, or an event that you can listen to easily for state, would be more ideal to allow for implementation changes. Again, I hope to have provided enough information to help you get started, and the next time you go to build something, I'd encourage you to try to build it with custom elements, as long as you don't have to support Internet Explorer.